Let's look at 66. On 308, and we have limit as x approaches infinity from 2x minus 3 over 2x plus 5, everything raised to, I think it's 2x plus 1. Is it? Yes. Okay. So when I plug in infinity, or I should say when I determine the limit, where does this go when x approaches infinity? Good. And now we apply L'Hopital's rule. Where does it go? Which is 1. So this goes to 1. Where does this go when x approaches infinity? Where does this go when x approaches infinity? Good. So it's 1 to infinity. It is the power, the most difficult one, I would say. Maybe not difficult, but the most involving one. The next step would be to name the function y The next step must be yes, of course. Very good. Indeed. The next step must be applying the limit to both sides. Limit as x approaches infinity from y equals limit as x approaches infinity from, let me not jump a step. Yeah, I didn't want to jump. Because I want to show this. Okay, so I have, I'm going to erase the whole thing because I don't want to wait. So this is limit as x approaches infinity from 2x plus 1 times natural log of 2x minus 3 over 2x plus 5. Okay, so where is this going now? Well, obviously, 2x plus 1 still goes to infinity. No question there. And the inside of the log still goes to 1. But now this goes to infinity, and this goes to 0. So I changed from 1 to infinity. I changed it now in this very step, applying natural log. I changed it into 0 times infinity, which is a much easier situation. This one only requires a simple algebraic manipulation. And the answer is no. Do not touch or move anywhere natural log. That would be a mistake. So limit as x approaches infinity. Natural log stays at the top. Now this becomes 1 over, or 2x plus 1 to negative 1. Better because I want to differentiate. So this is now 1 over 2x plus 1 that I flip, and I get 2x plus 1 at the top. But I'm getting it ready to differentiate it. So that's why now I'm trying again. This is a number that I bring as a fraction 1 over in the denominator. It's the same thing. So if I have 2 times 3, I can write 3 times over 1 over 2. I can bring this as a fraction in the denominator. Because when I flip it, I still get 2 times 3. So this was 2x plus 1 times some natural log. So I change it into natural log of that over 1 over 2x plus 1. But I prefer this as 2x plus 1 to negative 1 because I'm getting it ready to differentiate it. Is that better? Everyone? It's just a simple, I know it looks weird or difficult, but it's just a simple algebraic manipulation. If I have a product, I can bring any of these two as a fraction in the denominator because I'm not changing the problem. When I flip this, I get 2 times 3. Is that okay? Better? Perfect. So now I'm back, and now I will differentiate the top. Oh, let's check again. So the top still goes to 0, because this is 1, natural log 1 will be 0. And now this, it's 1 over infinity, which is 0. So we started with 1 to infinity, ugly. We got to much, somewhat friendlier, 0 times infinity. And now by this simple algebraic manipulation, I got to what I wanted. So limit as x approaches infinity, the top will be ugly. It's 1 over this, so I'm going to write 2x plus 5 over 2x minus 3 times. We could punish Elizabeth for choosing this, but it's the last class, so there is nothing we can do about it. We cannot ban her from choosing. Not in this class, anyway. Okay, so it's 1 over this, and now I have to differentiate the inside, which is a ratio. Top prime, 2, times the denominator, minus top times the denominator prime, over 2x plus 5 squared. And now the denominator prime is negative 1 times 2x plus 1 to negative 2 times the inner function prime. The reason is it has nothing to do with choosing it. I mean, it's a good example, very good example. Why is it so complicated? Because of that fraction inside the natural log. So when I differentiate the log, I have 1 over, so I have to flip that. But then I have to differentiate the inner function, which is a ratio. Is it done? Oh, no. It's not. So now, let's try and simplify it as much as we can. So the top, sorry, limit, of course. The top is, I will simplify 1 from here with 1 from here. And the denominator in the numerator is 2x minus 3 and 2x plus 5. I will factor out the 2, and it will go away with this 2. So then we have 2x plus 5 minus 2x plus 3 over negative 2x plus 1 to negative 2. Okay, let's see again. I got rid of one of these two. These two denominators stay. Then I have 2x plus 5 minus 2x plus 3. But when I factor out the 2, the top has a 2 and the bottom has a 2. And they go away. Okay. Now, nice. So I have limit as x approaches infinity from 8, with minus in front, there is a minus here, 8 over 2x minus 3 times 2x plus 5. This is 1 over 2x minus 1 squared, and I'll put it at the top. Because I have 1 over 2x plus 1 squared, which I flip. I'll take the negative 8. It's in the way. I don't care for it. I'll take it outside. And now, the numerator is 4x squared plus 4x plus 1. The denominator is 4x squared minus 6 and plus 10 and minus 15. And now you know the answer for this. 1, but times negative 8. Because if you differentiate, you'll get 8x and then 8 over 8, which is 1 with minus 8. Okay. Now, in the final step, I shouldn't say final, there is one more. I have to copy the beginning, and I have to copy the end. So when I copy the beginning, I have limit of y as x approaches infinity equals negative 8. sorry, please be careful. I applied limit to the left, which is limit of natural log y. Sorry about that. Because I wanted to swap the operators. I said, where is my operator? So I knew that I swallowed the operator. I cannot swallow the operator. So under conditions of continuity, which is the case here, I can write this. And you can change this into an exponential. Base raised to this equals this. So then limit of y as x approaches infinity is e to negative 8. I will replace y as the final step. Was it 2x minus 3 over 2x plus 5? Okay, thank you very much. Is e to negative 8. Do not tell me that you expected this, because I will never believe it. Very good question, very good pick. Next question. Today is December the 4th. Yes. Next topic, anything. Okay, let's browse again and see if we want to work on anything else. Between now and Wednesday, you can still call me or email me or whatever you need. So let's go back to test 2. I know you're fed up with differentiation by now. I know you're fed up with integration by now. In Calc 2, you're going to find, or you're going to learn other techniques of integration, like integration by parts and trigonometric substitution. You're going to learn about improper integrals. There are 2 different types of improper integrals. You're going to learn about applications of differentiation with finding volumes and areas between curves this time. Okay, and then you're going to look at series. Don't forget the total distance requires the absolute value for test 4, if you remember.
Like just doing the task, like if you can do the task, like, and get everything right, then you can get everything right on the
Yes. So if you get everything right on the final exam, what?
I'm just asking, like, because you keep saying, like, redo the test. I'm just saying if you can redo the test and get everything right,
I'm pretty sure you can.
there's a tendency.
I am pretty sure you can. There is nothing that you have not seen in class or on a test. You're obviously. I know everyone is tired towards the end of the semester, especially last week. Just hang in there. Just review what we reviewed again and the tests, and you should have no surprises, no difficulties whatsoever.
How many questions is that?
About 20 questions
And
roughly.
what time do we get
You have from 12 till 9. How is that?
there?
Can you finish between 12 and 9?
Okay. Of course.
Good. I know you can. So come in anytime you want from 12. Is there anything else?
Can we go over the fundamental theorem of calculus?
Which one? Part 1, part 2?
Part two.
Part 2, okay. So for part 2, if you have, for example, the integral, you're given a function. This is not an integral per se. It is an integral, but it's a function given as a form, in the form of an integral. For example, if you have 30 to 4x cubed from tangent x squared, tangent t squared dt, you can only be asked to find g prime, which means you only have to replace t by 4x cubed and multiply by 12x squared. If you forget to multiply by 12x squared, you're not using the chain rule. In this case, we have to use the chain rule. You're differentiating the integral, but you also have to differentiate the inner function. So when I differentiate the integral, I will get tangent of 4x cubed squared, which is 16x to the 6th. But I have to multiply by 4x cubed prime. And this is 4x cubed prime. I know I sound like a broken record, but if you get the chance, if you did not fill out the survey, please do it. Beyond Sunday, you will not have access to it. I know you don't need the 5 points, but if you could do that for me, I'll be very happy.
Is there any like optimization for domains, or is that?
Oh, yes. 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 Even in optimization, you use integrals. Well, if you don't have other questions, I can sit down with whoever wants to work more, and you can go if you like, or it's up to you. Or we can continue. Anything you want. I'm not going anywhere anyway, so it's up to you. Whatever you want.